Is the train moving or the platform? Motion is relative. What you perceive depends on your point of view. If you are standing on the river bank, it looks as though the barge is moving and the boatman is not. But if you are on the barge, it looks the other way around. Your view depends on where you are.
So, let's say we're on a bus, all right, a school bus. I'm actually with you, okay, sitting next to you in the seat. It'd be a little weird, but. So here's our bus. Got your door here, and you got your windows. Okay, we're sitting right here. And we're sitting in the bus, and the bus is moving along. And somebody behind us in one of the seats gets up and starts to walk towards the front of the bus. And I turn to you and I say, hey, what's the velocity of that guy? Just walked by us. And let's say he's moving at 1 meter per second. So you would say 1 meter per second. And then I look out the window and I see a guy standing here. And the bus is actually moving 5 meters per second this way. So I yell out to this guy, hey, what's the velocity of the bus? What does he tell me?
5 meters a second.
5 meters per second to the right, or east, or whatever you want to call it. And then I say, hey, can you see the person walking down towards the front of the bus? And he says, yeah. Right? And so that person's walking that way.
A lot is happening there.
And I say, hey, what's the velocity of the person walking? What does he say? 6, right? Because this person was moving at 1 meter per second that way, but the bus, in other words, the frame of reference that the person is in, is also moving. So then he has to say 6, because the person is actually changing position at 6 meters every second relative to his frame of reference, which is what?
Fixed.
Fixed, right? The street, it's fixed. The bus is moving, and then the person's moving. So we have a fixed frame of reference, then we have a moving frame of reference, and then we have something in that moving frame moving, right? So there's like 3 layers going on. If we go around the block and the person's still standing there, and by the time we do that, the person's now walking this way at 1 meter per second, I would yell out and I would say, hey, what's the person's velocity? What would he say? Now what's their velocity? He would say 4. Okay? So that's that. Now, let's have another scenario. So finally the bus gets to where we were going. Where we were going was a river.
So you take a lap on the block and then...
The weird thing about this river when we get there is it doesn't have a current. So it's just tranquil river, no current at all.
Is it like a lake?
No, it's a river.
Okay.
That's not flowing.
Stagnant.
Why? No, there's a boat in the river. I get in the boat, and you are floating in the water next to the boat. You're floating in the water next to the boat.
It doesn't look like a person.
And this guy happens to be there as well.
He's just following you.
He followed us. So he's standing on the land, boat's in the water, I'm in the boat, and you're floating in the water. And suddenly I start the boat, and I start to go this way at 4 meters per second. So now I yell out to you, I say, hey, what's my velocity? What do you say?
4 meters a second.
4 meters per second. We'll call this north. So you tell me it's 4 meters per second north. And then I yell out to this guy, hey, what's my velocity? What does he say? 4 meters per second north. Suddenly, by some weird freak of nature, the river starts to flow.
Is it like one of
The
those?
dam breaks.
What?
Is it like a lazy river? Like that you can go
I guess it has to be something I can control.
The dam breaks and then the water goes.
Okay.
It'd be more than
So the
3
river
meters.
starts to flow to the east. Okay? So now I call out to you who are in the water floating next to me, and I say, hey, what's the velocity of my boat? What do you say? 4 meters per second, because even though I start drifting this way, you're drifting also, right? And so relative to you, I still just go straight across at 4 meters per second. However, what the guy on the shore actually sees is my boat doing that, but while my boat's doing that, it's also doing this at 3 meters per second, right? So he's going to see me go off at an angle relative to him. And so if I say, hey, what is my velocity?
5.
He says 5 meters per second. And he also says at some direction,
Northeast.
right, north of east or east of north or whatever. Does that make sense?
Yeah.
So now you're telling me a different velocity than he was, just as was happening on the bus. So again, we have 3 different, 2 frames of references and the object we're interested in. So let's say we have, initially, we have the boat with respect to the water was moving at 4, right? So the boat's velocity relative to the water is 4 meters per second. Then to that, we add the velocity of the water with respect to what? The land, right, or the shore, we'll say the land. And once we add those together, boat to water plus water to land, we get what? Velocity of boat with respect to what? What's that 5 with respect to? The land, right? Now that gives us the boat to land is 5 meters per second at some direction. Here we had velocity of the person relative to the bus was 1. To that we added the velocity of the bus relative to the street, which was 5, and then we get the velocity of the person relative to the street. Okay, so we're adding 2 vectors, and we're getting our number. Now here, when the person was going towards the front of the bus, it was 1 plus 5, and it was 6. When he was going the other way, it was negative 1 plus 5, and it was 4. Here, boat to water was 4, water to land was 3, and it equals 5. Because it's a vector, right? When we're working with vectors that are not in one dimension, adding means using, right, triangles. It means using Pythagorean theorem, etc. Okay? So that's what we're looking at here. Now, the thing I want you to see, the pattern about the way I'm writing these subscripts is that you see that the B is kind of in the center, right? It's sandwiched between the other 2 subscripts. Just like the W is sandwiched between the subscripts we want. So that's the way to keep track of these vectors when you're adding them, is you write them out this way. These 2 that are kind of sandwiched in there basically get eliminated, and you get what you want. Same thing here. Whatever's eliminated, and you get what you want.